This lesson is going to be on solving linear systems graphically. So the next 2 or 3 lessons we're going to solve linear systems with different methods, graphically, substitution, elimination, and we'll go through each one of those in subsequent lessons. Now the first thing you need to know is, what does it mean to solve a linear system, and what is a linear system? So a linear system just means that you have 2 lines and you're trying to find this point here, which is called the point of intersection, sometimes a POI, a point of intersection. And a point of intersection has x and y coordinates. So it is a point. You have to find the x and the y value in order to say exactly what the solution is. So this would be the solution to the linear system. Okay, so the first one we're going to do, like I said today, is graphically. So graphically means you're going to graph them. So in order to graph them as accurately as possible so that you can get an answer that you can actually see, and you're going to see that graphically is probably the most unreliable method unless you have extremely good graphing skills, because obviously not every answer is going to be like 1, 2. It could be 1.375 or something like that, in which case it's really hard for you to determine that from a graph. So let's graph a few questions, and I have a couple of word problems, a mixture problem, and a distance, speed, time problem, which are ones that often give students a little bit of headaches, even teachers. Okay, solve by graphing, check your solution. So you graphed lots of things, lots of lines in grade 9, and this is going to be no exception. Nice, easy y equals mx plus b format here, right? So remember, m is your slope and b is your y-intercept. And remember that slope can always be written as rise over run, and if there isn't a number there, you can put a 1. So 2 over 1 is still 2. So that's my rise, that's my run. And if there's a 1 here, well, that's 1 over 1, right? Rise over run. So I'm going to graph this as accurately as I can to try to find where these 2 lines are going to intersect. So 2x plus 1, I go to 1, my y-intercept, and I'm going to go up 2 and over 1, and up 2 and over 1. And if I go right through all of those points as accurately as possible, 2 over 1, 2 and 1, 2 and 1. Let's get this right on, because if you don't get it right on, you're going to be a little lost on the end here. Okay, so that's pretty good for my pencil. I got to adjust for a little bit of width for my pencil here, and there we go. So you should put arrows on the end, and you should label your line, y equals 2x plus 1, and the second line, x minus 2. So I'm looking for a y-intercept of minus 2, so I'm here, and the slope is 1. So up 1, over 1, up 1, over 1, up 1, over 1, and I'm going to go through these little dots here. And how am I doing here? Hard time seeing. It's bright. Okay, so we're kind of here. Okay, so this is y equals x minus 2. And where's the point of intersection? It should be right here. So mine doesn't look like it's right on. Could be just off a little tiny bit. And because the answer is minus 3 and minus 5. So maybe you're a little better with the ruler than I am, and I have old eyes, so I might not be right through the dots. See, look, I'm off a little bit here, right? Should have been up a bit. So right like that. Okay, so my solution is minus 3, minus 5. Notice I have coordinates. And to check it, I'm going to substitute in minus 3 and 5 into each of these equations to make sure that this point satisfies the equations. And by satisfying, I'm saying that this point is on this line and it's also on this line. So if you have two lines, there's only one place they can intersect, right? And we're going to look at the different ways lines can intersect, maybe just briefly looking at it. We can have two lines that do this, right? You can only cross in one place. Lines don't wiggle back and around. So if you get more than one solution, something's really wrong. So one point like this, if they're parallel lines, there's not going to be any solution. We're going to talk about this again a little later. And the other option is that they're the very same line. So there's an infinite number of intersection points. They're the same lines. Okay, so back to this one here. Oh, we didn't check it. So to check, we're going to look at equation 1. So this one, so I'm going to say y equals 2x plus 1. Left side equals y is minus 5. Right side equals 2x plus 1. And I'm going to put in minus 3 for my x. And that's going to give me minus 5. So left side equals, left side equals right side. Left side equals right side. Okay, now that's not good enough just for one. I have to do the same for the second equation. So I'm going to write y equals x minus 2. Left side equals, well, it's just y. So y is minus 5. And the right side is going to be x minus 2. And that's going to be minus 3 minus 2. And that's equal to minus 5. So left side equals right side. So I've checked. So if you get the same answer on for both of them, left side equals right side, then that's good. You know, you're right. So you can always check your answer. The second equation, not equation, but thing we want to solve here is these two equations. And obviously they're not in a very nice format to graph. So in order to find the x and y intercepts here, you could do it a couple of ways. You could find the x and y intercepts, like I said, and join them. Or you could rewrite this into y equals mx plus b format. And that's what I'm going to do here. So I'm going to say 4y is equal to, I'm going to take 3x and put it on the other side of the equation, which means I change the sign and I move the 16 as well. So bringing it over the equal sign becomes plus, and then I'm going to divide by 4. So I have minus 3 over 4x plus 4. And that's not too hard to graph. This one, I'm going to bring the 2y over here this time because that's easier for me. So bring it over to the other side and switch sides. So I brought this over here and then I'm just writing it backwards. So 2y equals x minus 2. So I didn't move this, I just moved this one. So that's the only one that changes sign. And then I'm going to divide by 2. So I get 1/2 x minus 1. Okay, so now I'm in the right format in order to graph both of these. So y-intercept is 4. So I'm going to go 1, 2, 3, 4. I'm going to put my dot right there. And my slope is minus 3/4. So remember, if it's minus, you're going to go down 3, right 4. So I go down 1, 2, 3, right 4, 1, 2, 3, 4. And I should be able to join these now. Down 3, right 4. So that's my line. I'm going to write it out the same way as it was given in the question, in standard form. And the second line, I'm going to find my y-intercept of minus 1. I'm going to start here, and my slope is 1 over 2. So up 1 over 2, up 1 over 2. And look, that was a nice one because it landed exactly on the same point here, so I don't have to see if my line is straight. I'm there. So this point of intersection is 4 and 1. So I'm not going to do the check here because I don't have a lot of room and I don't want to waste your time. So if you plug in 4 here, 4 for x, that would give me minus 12, plus 16 would be 4, and y is 1. 4 times 1 is 4. So that worked for this one. Or you could plug it right back into the original equation. I could say x is 4, so 4 minus 2 times 1 is 2, and minus 2 more equals 0. So you can check that solution as well. Okay, so let's go on to some word problems. First one I'm going to do is a mixture problem, and these questions are pretty much from the Nelson textbook. I find sometimes the mixture questions give everyone headaches, and it's because they're not explained very well in the textbook. So I'm going to do my best to make sure you understand how to do these. So it says Jessica wants to make a blend of coffee that sells for $15 per kilogram and weighs 200 kilograms. She's going to use Brazilian beans that sell for $12 a kilo and Ethiopian beans that sell for $17 a kilo. How many kilos of each kind of bean should she use? Okay, so the first thing, we need to make up two equations. So she wants to make beans. She's making beans here. She wants to make 200, did I write that in here? Yeah, 200 kilos. So we're going to say, we're going to make a let statement. Let x represent the number of kilograms of Brazilian beans. And then y will be, let y represent the number of kilograms of Ethiopian beans. Beans for both of them. Beans, coffee beans. Okay, so the first equation we know for sure is that she's going to use so many kilograms of Brazilian beans and so many kilograms of Ethiopian beans, and they have to add up to 200 kilos. Okay, so there is another question just before this one in your textbook where they give you the graph and they ask you to set up the equation. So it's very similar to this one. Now, the second equation is the one that causes some problems. And again, I didn't find it well explained in the textbook, so I'll try to make it as clear as possible. The next one, we're going to figure out the number of kilos. So this is the number of kilos, and this is the price. So we have to add in these 15, 12, and 17. So she has Ethiopian beans at $12 a kilo. So our Ethiopian beans are Brazilian is 12. So we have 12 kilos, $12 times the number of kilos. So 12, this pencil's going to run out on me, I can feel it. $12 times the number of kilos. Remember, X was kilos. So $12, it's like me saying I want to buy 5 pounds of coffee at $2. So 5 times 2 is $10. That's what it's going to cost. But this time we have $12 times the number of kilos. And for the Ethiopian beans, they're $17, and the number of kilos equals. Now, the problem is people have trouble trying to decide what should go here. So I want you to think about it like this. So this was money, and this is pounds. We'll use the pound symbol. The number times the pounds, the value times the pounds equals, now I need dollars and pounds, right? I need to multiply these two things together. So what do I have on this side? What am I going to put here? So she wants to make 200 kilograms right here, and she wants to sell it for $15 a kilo. So this is going to be 15 times 200. Okay, so in the other question that was right before this one, if you have the Nelson textbook, they had 1,000 on your graph, and that was because it was 80 times 1250, in case that was a question you got stuck on and are looking at this one to try to make sense of it. Okay, so that means my second equation is going to be 12x plus 17y equals 3,000, right? 15 times 200. So there's my two equations, this one and this one. Now I want to graph them to try to figure out where they're going to intersect, because that's going to tell me how many kilos. So on this line, x is going to be representing my Brazilian beans in kilos. So this is kilograms of Brazilian. And this is going to be kilograms of Ethiopian. Okay, so if she made a mixture and she only used Ethiopian beans, then she would use 200 kilos of them, because she's trying to make a mixture of 200. If she only used Brazilian, she would have 200. So that's what this equation gives you, which you could also solve by saying, let's find the x-intercept. Set y to 0. Cover y, x is 200, y is 200. So there's my x and y intercepts, and that is sufficient for me to make a line. Right, this is my line, x plus y equals 200. I'm going to draw a line through this one. Okay, it's not going to go through or past the x-axis here because you can't have a negative number. So it's just going to stop there and there. Now the second equation though, 12x plus 17y is 3,000. I need to find the x and y intercepts. So for x-intercept, we're going to set y equal to 0. So if I do that, then I get 12x equals 3,000. And that means x is going to be equal to 250 if you divide that out. Now for the y-intercept, we set x equal to 0. And that means I'm going to have 17y is equal to 3,000. And this doesn't nearly give you as nice an answer. You get y is 176.5. So now you can see how this is going to be difficult when you're trying to solve using a graph, right? How accurate can I be? So if x is 250, sorry, the x-intercept is 250, and the y-intercept is 176. So y is my Ethiopian beans, so I'm going to have 176 here. So I went by 20s. So 176 is going to be just below the 180. So I put a dot about here. And again, this is why I don't like graphing, because it's so iffy. And 250, that's 20, 40, 50. The other line's going to be out here. And then I'm going to join these two here and then try to figure out how much of each bean I should be using. So now you have to estimate what this solution is here. And that's why graphing is so difficult. Like, how many is that? Well, it's not too bad because it looks like it's about 120 here. And this one is about 80, right? So this one, we got kind of lucky with this one, 120 and 80. So if you figured 120 and 80, 120 and 80, so 120 plus 80 is 200. That worked nicely. But let's see how well it works into equation 2. So if x equals 120 and y is equal to 80, then I would have 12 times 120 plus 17 times 80. Is that equal to 3,000? Now I'm going to be in trouble because I don't have a calculator. So 12 12s are 24 or 144. So 1440. And this 17 times 8, 56, 5, 8, 136, 0. Is that equal to 3,000? 10, 6, 10. It is. Okay, hooray, hooray. So that means this is the correct solution, right? But again, remember we're graphing it, and sometimes if you're not really accurate, this doesn't work out so well. And again, we'll get into some better ways to solve equations. I think this is more important that you learn how to set up an equation for a mixture. Okay, so the last question I want to do is distance, speed, time question. And this one says that Arthur drives 393 kilometers from Ottawa to a fishing lodge near Temagami. He travels at an average speed of 70 kilometers an hour to North Bay, then 50 kilometers an hour from North Bay to Temagami. The trip takes 6 hours. Now, I used to drive that road often, and no one is going 70 kilometers an hour or 50 from North Bay to Temagami, but it works for the question. You should go up there if you've never been. Temagami is beautiful. My hometown is Kirkland Lake, if some of you know where that is. So the trip takes 6 hours. Write two equations. Okay, so we have time. And time, distance, speed, time. Do you remember how if I went 5 hours at 70 kilometers an hour, I would have driven 350 kilometers, right? You know how to do that. Okay, so let X represent time at 70 kilometers per hour. Okay, so we need one for X and one for Y, and it's going to be the time at 50 kilometers per hour. How much time we spent doing each. Okay, so the trip takes 6 hours, so that means the first equation we're going to have is that X plus Y is equal to 6 hours. That's pretty easy. Now the second equation, we're going to use the distance. So if I go 70 kilometers an hour, 70 kilometers an hour for a number of hours, that's going to give me a distance, right? So if I said I went 70 kilometers an hour for 2 hours, you would know that I went 140 kilometers. And the second one, I'm going to go 50 kilometers an hour for Y hours. And that's going to give me the total distance, because remember, this is going to give me distance, right? And I want that to be equal to 393 kilometers. So there's my two equations. Now, for graphing it, I need to find X and Y intercepts here. So for this one, we either went all the way, so I did 1, 2, 3, 4, 5, 6. So I either go all the way 6 hours going one speed. So let's write this on our axis here. Y was 50 kilometers an hour. 50 kilometers an hour. Time at 50 kilometers an hour. And this is going to be time at 70 kilometers per hour. And so it's either 6 there or 6 here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so that's the easy one to graph. 6 and 6. So this is X plus Y equals 6. And then this one, I need to find X and Y intercepts. So if I divide 393, I hope I did this somewhere because, like I said, I don't have 393 divided by 50. That's going to give me 7.86. And 393 divided by 70 is going to give me 5.61 if you do this on your calculator, okay? So 5.61, that would be my y-intercept. So y-intercept set x to 0. So y-intercept is 7.86. 7.86. So 7.86 is going to be about here. And the other one, which is my x-intercept, let's write that out. For x-intercept, set y equal to 0. So 70x is equal to 393. and x is approximately equal to 5.61. Okay, let's write that out for the other one as well, just so you've got it. Set x equal to 0, so 50y equals 393, and y is equal to 7.86, approximately both of these. So I've got 7.86 up here, and the other one is 5.61. 1, 2, 3, 4, 5, 5.5, 5.61 maybe. Okay, so now I'm going to join those two like this. And there we go. So you can see this is going to be really difficult to figure out the solution to the last part of the question unless you had a graphing calculator. So it's about here. And it says, so we graphed it. Now it says use a graph to determine the distance from North Bay to Temagami. Well, we can try to figure out how many hours it was. So this is at 50 kilometers will be my North Bay to Temagami. So I want to read the y coordinate. So I'm going to dot that across here. So it's about here. And the x coordinate, of course, would be the other one, which would be about here. So 1, 2, 3, 4. This would be 4, 5. So this is more than 4, probably, I don't know, 4.6 or something. And the y, see, this is 1.5. And in your textbook, it says it's 1.35. Now, I don't know how they could be so accurate looking at this. I mean, I would definitely say it's under 1.5. And this is, you know, I'm trying to be as accurate as possible. But the solution comes out to 1.35 hours. Now, I don't think whoever wrote your textbook actually estimated that from a graph. I think they probably used a different system. They probably solved using elimination or substitution to get such an accurate amount of time. Because I can't read that as 1.35, can you? Okay, so if 1.35 hours, now that's not the distance, that's the time. So I have to do 50 times 1.35 to get approximately 67.5 kilometers. Okay, that's how many kilometers he went from North Bay to Temagami. Okay, so that's your lesson on solving by graphing. It's difficult, like I said, using a graph and being super accurate, but it's it's a skill. It worked quite well for those first few questions that we did when we had the equations. I mean, that's pretty easy to find these points off these graphs if you're, even decently accurate, and you can check them. But getting a 1.35 here, I think that's a pretty big stretch. And like I said, we'll find other ways of solving these in the next few lessons. So I hope that helped you. And please subscribe and tell your friends to join in. And if you're in grade 10, there's all of grade 11 and all 2 grade 12 courses there for you as well. All the best. Bye for now.